This series of lectures is going to talk about electricity because many of you are going to be using electricity in your careers and in your studies here, even if it's not directly with your arts. You all use computers and many of you use different types of equipment with electricity. So I'm going to go through the basics of how electricity works. So before we can get into how electricity works, we do need to talk about the atom. So the atom has some parts that we need to review. I know some of you, this is probably a review for. So we've got the nucleus, and the nucleus is made up of two types of particles. We've got protons here in the nucleus, and these are the positively charged particles. And so they're going to have positive electric charges for what we're talking about. They're going to hang out with the neutrons. And I remember neutrons are neutral because they begin with the same set of letters. And the neutrons are just going to hang out. They're not going to really affect anything. Then we've got the electrons. The electrons hang out in their own space around the atom, out in what we call the electron cloud. These guys are the negative charges. And these are important for things like electricity because these electrons can be transferred. They can be moved around from atom to atom and material to material. So we'll see that these play a huge part in electricity. So as a whole, atoms are considered electrically neutral until they start losing or gaining electrons. And this is because, like this helium atom, atoms start off with equal numbers of positive and negative charges, equal numbers of protons and electrons. So you can see here, we've got 2 protons, 2 electrons, so they cancel each other out as far as positive and negative charges, and so it will be electrically neutral. So when they are no longer equal, so when they gain or lose electrons, that's when they are going to have an electric charge. So electric charges do come in 2 types. We call them positive and negative. And so atoms and objects can both be positive or negatively charged depending on whether they've gained or lost electrons. And electric force related to electricity is produced when these charges are interacting with each other. So when we have 2 charges of the same type, so for example, 2 positive charges, they're going to repel each other. They are not attracted to each other. They're going to push apart, and that can produce force. Same if they are opposite. So opposites do attract in this case. And so unlike charges or opposite charges are going to be attracted to each other, and they will create a force as well. And so these 2 types of reactions can create electric force that we can use for work. So conservation of charge, this is how we get charges to move from one object to another. Well, it's related to how we can get charges to move from one object to another. Conservation of charge is just going to say in any charging process, so when electrons are moving from one place to another, they're not created or destroyed. They don't just show up. They are just transferred from one material to another or from one atom to another. So charging processes, they can be what we'll talk about with current electricity, which would be supplied by something like a battery or a generator, or it can be a charging process like you see down here where we rub 2 objects together, and that can create a charge as well. So let's take a look at what we have down here. We have a piece of amber and a piece of cloth. And when we start, they are both neutral. They have a net zero charge because if you look, the charges are equal. They have equal numbers of positive and negative charges. The charging process in this case is friction, so rubbing the objects together. And during that process, some of the electrons get moved. In this case, the amber gets the electrons, the cloth gives them up. And so the amber gets more electrons, which means it's going to become negative because it has more electrons now than it does protons. And then the opposite's true for the cloth. The cloth is going to become positive because it has more protons than electrons. And the protons stay. Remember, those protons can't move out of the nucleus. So items that lose electrons are going to become positive because those protons can't move. And then the ones that gain the electrons are going to become negative. And so conservation of charge is just the same sort of idea as the laws of thermodynamics, right? You can't destroy or create energy, it just gets transferred. Same thing here, just with electrons. So electrostatic charge, I just want to talk about briefly. It's not in your textbook, but it is important and it's something that you've experienced. So electrostatic charge is a stationary charge confined to an object. This is different than what a bulk of what we're going to talk about here is. Most of what we're going to be talking about in this chapter is what we call current electricity or current charge, where it moves, but here it's a stationary charge. And this is a pretty familiar way you can get electrostatic charge that you probably have experienced at some point. And that is either using a comb or a brush on your hair. And so when you start, both your hair and the comb or brush are neutral. They both have a net zero charge. But as you start to comb or brush your hair starts to give up electrons. So the materials that we are made out of tends to give up electrons when we encounter other materials. And so those electrons get transferred, in this case, to the comb or the brush. That makes our hair positive as a charge, and it makes the comb or brush negative. Now, since your hair now is positive, that's why it does the little stand-up trick and poofs out, because the hair is now positive and doesn't want to stay next to each other. They have the same charge. They're going to want to repel each other. If you bring the comb or brush near your hair, you'll probably have noticed that your hair is attracted to it, and that's because they are opposite charges. The thing with electrostatic charge, the objects will return to their neutral state if you give them time. So it'll especially happen quickly on humid days. If you've noticed, this hair stick up trick doesn't work really well in the middle of summer, but it works pretty well here in Ohio on a dry, cold day. That's because the water in the air is going to tend to either give up electrons or take electrons from those objects to discharge them and bring them back to neutral. So how can we get an electrostatic charge in an object? So you can charge them in one of three ways. One is friction, so transferring the electrons from one object to another, literally transferring them, so rubbing them together like with the amber and the cloth, or some of you may have done the carpet zap with siblings or friends, where you shuffle your feet on the carpet. When you do that, you're leaving electrons behind, so you become positively charged. And then when you touch someone else, you are then positively charged and they're neutral, so you get zapped. So there's friction, there's contact. So this is where a charged body touching an object and transfers electrons or takes electrons. So a contact one that you may have seen if you've ever seen the demonstrations at like science centers with the big bell that somebody touches and then they touch somebody else and makes their hair stand up. That would be an example of a contact. Induction, this is redistribution of charges in a material. So this one's really interesting because this happens without the charged object touching the other one. So got a picture down here, got a piece of paper. The charges are equally distributed. So you can see there's equal numbers of positive and negative charges. Bring that negatively charged comb near the paper but without touching it, and take a look at what happens to the charges. The comb is negatively charged, so it's going to pull the positive charges towards that side of the paper. And what that'll do as well is it will now pull the paper towards the comb. And so eventually, if the paper is light enough and you bring the comb close enough, the paper will actually be pulled close and stick to the comb. Induction is a pretty common way for electrostatic charge to be transferred. And there is a video that's posted after this with some different experiments. I will post both versions, one with narration on how these experiments are working and one without, so you can take a look at them. But these all include electrostatic charge via induction. All right, I'll pick up in the next video talking more about properties of electric charge and electricity.